Welcome to AERO 2230 ProPilot 1, presentation number 12 on aviation weather reports and services. We'll be discussing printed weather reports, for example METARs and the information included in METARs, radar weather reports, PIREPS, and broadcasted weather reports like ADIS, ASOS, AWOS, and HIWOS. We'll look at weather forecasts, including terminal aerodrome forecasts or TAFs, area forecasts or FAs, and winds and temperatures aloft forecast. Other reports include AIRMETS, SIGMETS, and convective SIGMETS, and we'll look at other sources of weather information as well. The first report that we need to discuss is the METAR, which is the Aviation Routine Weather Report. These reports are done only for larger airports in Class Charlie or Class Bravo airspace, and they're published at least once an hour unless there's a special report that's labeled SPECI, S-P-E-C-I, for a large change in the weather. Here is a METAR for the Nashville International Airport, or KBNA. KBNA is Nashville's designator, and you can see that's the first thing in the report. The next two numbers are the day of the month, the 22nd, and then the next few numbers are the time that the report was issued, 1739 Zulu or UTC. The next numbers represent the wind direction and the wind speed. So the wind direction was from 110 degrees, 110, and the wind speed was 4 knots. The next numbers represent the visibility, 10 statute miles visibility, and then we had cloud heights. SCT is abbreviation for scattered clouds. The first number, 016, it represents 1,600 feet. So this airport has scattered clouds at 1,600 feet, and then another layer of scattered clouds at 6,500 feet. And then finally there's a broken ceiling at 15,000 feet. The next two numbers are the temperature and the dew point. So the temperature that day is 13 degrees Celsius. This is always in Celsius. And the dew point is 8 degrees Celsius. A stands for altimeter setting, and at this time the altimeter setting was 30.00. And then you have remarks. And this remark, A02, stands for an automated weather report, and 02 means that the report or the station has the capability to discriminate different types of precipitation. So just a few things about the METAR. Visibility is always stated as prevailing visibility, and it's always given in statute miles. There are some abbreviations that you should get to know. TS stands for thunderstorms, SH is short for showers, FZ is for freezing, and BL is short for blowing. Sky conditions are always stated as SKC, sky clear, FEW means few clouds, SCT means scattered clouds, BKN means broken clouds, and OVC means overcast. Only broken and overcast constitute a ceiling. Few and scattered do not constitute a ceiling. Here are some examples of METARs from different airports. The first one at the top is KBOS, which is Boston Logan Airport, issued on the 25th of the month at 12:54 Zulu. The wind was from 300 degrees at 9 knots, and the visibility was 10 statute miles. The cloud cover was few at 5,000, and the temperature was 6, and the dew point was 0 degrees Celsius. Altimeter setting was 30.03. And the remarks state that the report is an automated report with precipitation discrimination equipment. SLP stands for sea level pressure, and T is for temperature, and that's just an accurate temperature to and dew point to the 10th. So the temperature was actually positive 6.1 degrees Celsius, and the dew point was 0.0 degrees Celsius. The unit of measurement for sea level pressure is in millibars. SLP 168 stands for 1016.8 millibars. If the pressure were below 1000 millibars, then the first number would be a 9. Here's an example of a METAR with a different reading for visibility. The visibility is 1/2 statute miles, but it also states that on runway 36 left, the ground visibility is 2,400 feet. Below that you see some remarks. We've already talked about AO2 as signifying the type of METAR equipment. TSB stands for thunderstorm began, and that's 24 minutes after the hour. RAB stands for rain began, 24 minutes after the hour. Weather radar products make it easy for you to track the location, intensity, and also the direction of movement of precipitation. Here you see a radar picture showing very intense precipitation in purple, less intense in the dark red and the light red, and then moderate precipitation is shown as yellow. And then the green area signifies light precipitation. PIREPS is short for pilot reports, and pilot reports are given by pilots to air traffic control, usually about unforecasted weather that's been observed. For example, cloud bases, icing, turbulence, all can be reported by a PIREP. Here's an example of a printed PIREP. UA stands for PIREP, and OV stands for over. GZG is the VOR that the aircraft was located near, and 270 is the radial of the VOR. 045 is the distance from the VOR on the 270 radial, so that's exactly where they were located. TM stands for time, 1651 Zulu, and FL stands for flight level or altitude at 7,000 feet. TP is a type of aircraft. A BE-35 is a Beechcraft, I believe a Bonanza. TA is the abbreviation for temperature, and that was 0 degrees Celsius. And then the last portion is a report about the weather. TB stands for turbulence, moderate to severe. A METAR is a report about current weather at an airport. But we also need to have forecasts about future weather or prediction of weather in the future. And we can get that through a terminal aerodrome forecast or a TAF, area forecasts for certain areas, and winds aloft forecast. Terminal aerodrome forecasts or TAF apply to a big airport and only to a certain area around the big airport, about 5 nautical miles. TAFs are usually issued for Class Charlie, Class Bravo airports, and again, it only covers an area of 5 nautical miles around the airport. It's issued 4 times a day, but they may issue an amended report if something significant changes. It uses many of the same elements and same abbreviations as a METAR, and each TAF is valid for 24 hours. Here's a TAF for the Nashville International Airport, KBNA. This report was issued on the 22nd of the month, which is the number after the airport designator, at 1720 Zulu, and the next set of numbers is the valid time. This report is valid from 1800 Zulu on the 22nd of the month to 1800 Zulu on the 23rd of the month. The wind is forecasted to be variable at 3 knots. Visibility is forecasted to be +6 statute miles, and the clouds are forecasted to be scattered at 7,000 feet. But then you see the next line, FM stands for from. So from the 23rd at 0000 Zulu, the wind is forecasted to change to 290 at 8 knots. Visibility will be the same, +6 statute miles, but the ceiling, the cloud cover, is forecast to change to broken at 7,000. Area forecasts cover a much larger area than a TAF. However, they have been discontinued for the lower 48 states. They are still issued for the Gulf of Mexico, Alaska, Hawaii, and the Caribbean. But for the lower 48 states, the area forecast has been replaced by a graphical forecast tool. Here is a picture of the graphical forecast tool on aviationweather.gov. And you can see that there are symbols all over the lower 48 that tell you what the weather is forecasted to be at certain times in the future. There's a legend at the bottom to help you translate the different symbols. At the top, you see that you can change the time in the future to look at the forecast. So you can look at 1400 Zulu, 1500 Zulu, 1600 Zulu, and so on and so forth. The graphical forecast tool for aviation was designed to provide aviation weather to give users a complete picture of how the weather may impact the continental U.S. It can be viewed from 14 hours in the past up to 15 hours in the future. You can also look at ceiling and visibility by clicking CIG/VIS at the top, and you can see that the ceilings and visibility are signified by different colors on the map, and below at the bottom you can see the legend to help you translate these colors. The red arrows on this slide tell us what type of a forecast has been requested on the GFA. This is a forecast for ceilings and visibility, and it was requested for 1300 Zulu in the future. When looking at these reports, it's important for you to understand the different types of weather and the definitions of those types of weather. VFR weather is defined as a ceiling of greater than 3,000 feet and visibility greater than 5 statute miles. Marginal VFR is defined as a ceiling between 1,000 and 3,000 feet and visibility between 3 and 5 statute miles. IFR weather is defined as a ceiling between 500 and 1,000 feet or less than 1,000 feet and visibility of 1 to less than 3 statute miles. And then low IFR is defined as a ceiling of less than 500 feet, AGL, and visibility less than 1 statute mile. We've used the winds and temperatures aloft forecast to do our cross-country planning. It's important for you to remember that the wind direction given on the winds and temperatures aloft forecast is true, not magnetic. Wind speeds are given in knots, not miles per hour, and you won't see a wind speed or direction if the airport elevation is within 1,000 feet of the altitude block. You can get a winds aloft forecast from aviationweather.gov, and remember to look for the times for use and request the report that's closest to the time of your planned flight. Remember, if you're going on a long flight, the winds aloft are going to change as you get further from your departure airport. So you have to adjust your flight planning for the changes in wind, because your wind correction angle is going to change, your ground speed will change, and as a result, your estimated time en route and your fuel burn is going to change. There are 3 severe weather forecasts that you should become familiar with. They're the Hurricane Advisory, or WH, the Convective Outlook, or the AC, and the Severe Weather Watch Bulletin, or the WW. A hurricane advisory is issued when hurricanes are within 300 miles of the coast. There's no specific details given for time of arrival, since that can vary, but it's important for you to keep an eye on this, especially during hurricane season. A convective outlook is issued and covers 3 24-hour periods when there is a chance that thunderstorms will occur. Slight, moderate, or high risk of thunderstorm activity is forecast in a convective outlook. And a severe weather watch bulletin defines different areas of severe thunderstorms or tornadoes. 3 in-flight weather advisories that you need to understand are the AIRMET, the SIGMET, and the convective SIGMET. AIRMETs and SIGMETs are weather advisories that will be broadcast by air traffic controllers as they are released. AIRMET stands for Airmen's Meteorological Information, and they're issued every 6 hours for conditions that are of interest to all aircraft, but of particular interest to small general aviation aircraft. There's a AIRMET Zulu, an AIRMET Sierra, and an AIRMET Tango. AIRMET Zulu is specifically for icing. AIRMET Sierra is for IFR conditions, and AIRMET Tango is for turbulence. SIGMETs are issued for severe weather conditions that aren't associated with thunderstorms. Hazardous weather that is significant to both small GA aircraft as well as large transport aircraft. And it can include things like dust storms, sandstorms, volcanic activity, ash clouds, severe icing not associated with thunderstorms is also something that SIGMETs are issued to report. Whenever you see the word convective or convection, it refers to thunderstorms. So a convective SIGMET is hazardous weather conditions associated with thunderstorm activity or convective activity. This is weather that's hazardous to all aircraft. Tornadoes, lines of thunderstorms, thunderstorms over a wide area, embedded thunderstorms, and hail greater than or equal to 3/4 of an inch, and wind gusts of greater than 50 knots. There are also graphical weather products that are available from aviationweather.gov. One is called a surface analysis chart, and that's a PROG chart. PROG is short for prognostic, so this is a forecast or a prediction. And it shows air masses and frontal areas and their movement. It also shows isobars. Isobars are lines of equal pressure. And remember, when those isobars are very close together, that means that the wind is going to be very strong in that area. Here you see a PROG chart, and the PROG chart is divided into 4 separate sections. The left section is the 12-hour forecast, and the right section is a 24-hour forecast. The top half shows ceilings and visibility, icing or freezing levels, and also moderate or greater turbulence. The bottom 2 show high and low pressure areas and also fronts and their movement, as well as the precipitation associated with each of those fronts. SDs stand for radar reports, and radar reports show areas of precipitation. Usually they're issued every 35 minutes past the hour, and it can give you the type, location, and intensity of precipitation. Here is a radar report showing different areas of precipitation and different intensities of that precipitation. There's a legend in the lower left-hand side of the slide that you can't quite see that tells you how to interpret these symbols. Another source of weather information is the flight service station. You can call the flight service station and get a standard weather briefing before your flight. The phone number to do that is 1-800-WX-BRIEF, and that's available 24 hours a day. That number will connect you to a local flight service station, and you can ask for a standard weather briefing for your flight. After you get your weather briefing, you can also file a flight plan. When you first call the flight service station, you should ask for a standard VFR briefing. After you get your standard briefing, if your flight is delayed and you want an update, you can call back and ask for an abbreviated briefing. If you're scheduled to fly in the future, more than 6 hours into the future, you can call and ask for what's known as an outlook briefing. TIBS stands for a Telephone Information Briefing Service, and you can receive a TIBS by calling the flight service station, or there are specific published numbers for TIBS in certain areas. It's a continuous broadcast of automated weather report, and it can even include METARs and TAFs. After you take off, if you notice that there's weather that wasn't forecast, it is possible to get an update of weather while you're in the air in a couple of different ways. You can call the flight service station on the radio to get an update on the weather. There's also a service known as Flight Watch, which is EFOS or En route Flight Advisory Service, and you can reach EFOS or Flight Watch on 122.0 below 18,000 feet. Some air traffic control facilities have radar which can tell you the intensity of precipitation ahead on your route. You can listen to HIWAS, which is Hazardous In-Flight Weather Advisory Service. That's a continuous broadcast on specific VOR frequencies. Hazardous In-Flight Weather Advisory Service can be obtained by looking for VORs with a little H in a circle in the upper right-hand corner of the information box on the sectional. If there's a HIWAS associated with the VOR, all you have to do is tune in the VOR on your navigation radio and then turn up the volume so that you can listen to the broadcast. AWOS is short for Automated Weather Observation System. Those are automated weather reports that you can listen to at different airports. Murfreesboro has an AWOS that you can tune into the radio, you can listen to on the phone. Some airports have an ASOS, an Automated Surface Observation System, which provides minute-by-minute observations, and it reports all the information that's contained in a METAR issued for a certain airport. Large controlled airports with a tower usually have a service known as ATIS, Automated Terminal Information Service. That is an automated broadcast. It's updated every hour, usually at 55 minutes before the hour. It provides all the weather information about a larger, busier airport, and it's recorded by the air traffic controllers in the tower. Each observation is defined by a letter, so every hour the letter is changed. So you may hear ATIS information Alpha, ATIS information Bravo. The purpose of the ATIS broadcast is to reduce the workload for air traffic control so that they don't have to tell the same information over and over again to pilots as they're contacted. That's the end of presentation number 12 on aviation weather reports and services. You can get more information about aviation weather reports in Chapter 7 of the textbook. Our next presentation will be on federal aviation regulations.